back to the deep dive. Today we are preparing for a bit of a quantum leap. We're looking at a theory that challenges physics right down to its very core.
It really does, because for centuries, going all the way back to Newton and then later codified by Einstein,
Right.
our entire understanding of the universe has relied on this one foundational and maybe a restrictive idea.
Mass. The letter dollar.
Exactly.
Yeah.
Mass. We use it to calculate momentum, force, energy, everything.
And if you take it away, the whole system it falls apart. The physics becomes inexplicable.
And that gets us right to the heart of the question that Nishant Kumar Sharma's theory is trying to solve.
Because
If a basic unit of a field possesses energy, how does that energy actually become the thing we call mass? How does it physically manifest?
So this is our mission for this deep dive, to really unpack the origin story of mass from the lowest possible energy level.
And we'll do that through a framework Sharma calls non-interactive mechanics, or NI mechanics for short.
Okay, so where do we even begin?
We have to start at the absolute bottom. The theory introduces a new concept, non-intractable particles, NI particles.
Non-intractable.
Right. And these are field quantas that exist at the zero HV energy level. Think of it as the ground floor of reality.
And what makes them so special?
Well, here's the critical part. Their interaction with established matter, so particles, at the 0.5 HV level or higher.
Like electrons, protons, things we know.
Exactly. Their interaction is negligible. They don't really exchange energy with matter in the way we'd expect.
So who do they interact with?
Primarily, they interact with each other.
Okay, that's immediately counterintuitive.
Yeah.
If these particles are supposed to be the source of mass, but they don't interact with mass, how can they create it?
That is the big question. And their characteristics are strange. They have approximately zero mass.
Both at rest and when they're moving.
Both. And yet, despite having no mass and not really interacting in a classical sense, they hold the ability to lead the mass field.
Lead the mass field. What does that mean exactly? If it has zero mass and doesn't interact, how does it physically lead anything?
You've hit on the key conceptual hurdle.
Is it like
A blueprint. Is the NI particle providing a kind of geometrical or statistical framework for mass to follow rather than being the mass itself?
That's a perfect way to put it. It's not the brick, it's the architectural plan for the brick.
Interesting.
And these particles, they're indistinguishable. They only move in a straight line, which is why they don't scatter off of other particles. And statistically, they obey Pauli's exclusion principle.
Okay, Pauli's principle. So no two identical particles can be in the same quantum state at the same time.
Right. And because they have a spin of 1/2, the math requires that the number of available cells, or states, let's call them Tsire dollars, must be much, much greater than the number of particles, $9, occupying them.
Which suggests a field that's almost infinite in its capacity for potential states. There's always more room. It is that enormous capacity, that statistical framework, that leads to the theory's most fundamental redefinition
of what a quantum unit even is.
Exactly. It all boils down to this deceptively simple equation.
Let's hear it.
N plus M equals 0.
N plus M equals 0.
Okay,
let's break that down. No dollar is the field of these non-intractable particles.
That's correct. And non-dollars is the established matter field, the stuff we can see and measure.
So the union of the non-intractable particle and the matter field equals a class 0 particle field.
But what that means is the real breakthrough here. It means a field quanta isn't just matter, it's not just knowledge.
It's both.
A field quanta is fundamentally defined as the inseparable union of the non-intractable particle and the matter field.
Wow. Okay, so pure isolated matter. It doesn't really exist at this fundamental level.
That's the implication. It's always defined by its relationship with this non-interacting zero mass background field.
That completely changes how we think about what something is. So if everything is this union, what sets the stage for that union to actually acquire mass?
It requires a stage with a very specific layout. The theory says it needs two distinct geometries.
Two geometries.
Correct. Provided by the matter field. They're equal in amount, but they're opposite in nature.
And the first one is?
The first is called positive Kerr geometry. This is the one that is cell-occupied.
Cell-occupied. So thinking about that in a more tangible way, it has the physical structure needed to hold information, or in this case, to hold mass.
Precisely. It's the vessel. And this geometry dictates a right-handed rotation.
No HR.
Right. The theory uses a great real-world analogy, the rotation of planets around the sun. That's a macro-level example of this prime mass-holding geometry.
So what's the other side of that coin?
The negative curve geometry.
Which would be? Cellless.
Exactly, cellless. And it has a left-handed rotation. This cellless nature means it can't really hold on to mass for long. It acts more like a neutral or a transmission state.
And you need both. This dual opposite geometry is the key.
It's essential because it sets up the precise mathematical mechanism for how these zero mass potential particles can finally gain mass.
Which brings us to the moment of transition itself. How does an Ni particle get from that base 0 HV level and jump into the matter field at 0.5 HV?
This is a process the source calls Ramanujan entering.
Ramanujan, as in the mathematician Srinivasa Ramanujan.
The very same. The procedure is based on one of his more famous mathematical relations.
Which one?
12n equals -1.
12n equals -1. Okay, that's not intuitive. 12 of something equals -1. What's the physical meaning of that ratio?
It dictates the exact recipe for the transition. You need an overwhelming positive bias.
Meaning?
12 Ni particles have to follow the positive curve geometry. Those are the mass-holding states.
Okay, the 12.
And at the same time, one Ni particle has to follow the negative curve geometry, the mass-leaving state.
The -1. So the 12 are building the structure in the mass-holding field, and the 1 is, counterbalancing it, stabilizing the action.
Yes, that's a great way to see it. And the really significant part is that once this very specific 12-to-1 procedure is complete,
The mass appears.
those 12 particles instantly gain the mass field and the relative state they need to have a concrete mass value.
That is fascinating.
And here's where it gets even more exciting. The sources you sent over point out that NASA, when they were observing a particle emerging from a black hole, actually saw a process that looked a lot like this theoretical entering procedure.
You're kidding.
Not at all. It's an alignment between a subatomic statistical model and, extreme astrophysics.
That is a stunning convergence, from the smallest possible scale to the largest.
It really is.
So Ramanujan entering is the trigger, but the overall sustained process of interaction is called the Nishant Effect. What keeps that effect going?
The Nishant effect requires the matter field to follow what the theory calls a tri-nature property.
A tri-nature property, what does that involve?
Well, the source implies three core things have to be in place. First, you need the dual geometries we just talked about.
Positive and negative.
Right.
Second, you need that continuous energy exchange, the whole Nowler plus M union. And third, and this is crucial, you need a particle count bias.
Whole particle count bias.
Yes. The effect only works if the number of particles is always greater than the number of antiparticles.
Why is that?
Because that positive curve geometry, the mass-holding cell-occupied state, has to remain the dominant influence in the system.
Connecting this to cosmology, that sounds a lot like a mechanical explanation for the matter-antimatter imbalance in the universe.
It could be. The idea here is that the creation of matter is structurally baked into the geometry of the field itself.
So it's not an accident that we have more matter than antimatter, it's a requirement.
According to this theory, yes. And this whole mechanism then leads directly to how stable elementary particles form.
How so?
After the Ni particle enters and gets its mass potential, the original matter field actually splits into two parts.
Okay.
The first part is called the dense energy field.
Let me guess, that's the positive curve geometry. You got it. The cell-occupied state. The Ni particle that settles down in this field becomes the stable, right-handed rotating proton. This field is dense, it holds and concentrates that new mass.
And the second part would be the transmission mechanism, the spread energy field.
Exactly. This is the neutral field, the negative curve, the cell-less geometry. A second Ni particle takes some of that mass property from the dense proton field and transmits it over here. The unstable, left-handed, rotating electron.
So the dichotomy is just. It's incredibly elegant, a stable, dense field for the proton, and an unstable spread field for the electron.
And both come from the same initial $1 plus M union. It's a clean structural model built entirely on geometry and statistics. It's a full mechanical loop for turning zero mass potential into the building blocks of matter.
Okay, now we have to get into the claims that really start to push the boundaries of, all of established physics, the proofs.
Right.
And the most provocative one has to be about the speed of these Ni particles.
I agree. The theory claims they travel faster than the accepted speed of light.
How much faster?
The calculated velocity, which they call CNI, is 299,813,275.22 meters per second.
Okay, let me Let me put that in perspective for you.
Yes.
That's about 20,800 meters per second, faster than the speed of light we use in all our equations.
It's a massive claim.
So does NI mechanics just throw out special relativity? Is Einstein wrong?
That's the critical question, and the theory suggests no, it doesn't discard it, it incorporates it as a kind of special case.
How?
It claims to mathematically prove the equations we already know are fact, like EMC22.
Proves mass energy equivalence.
And the full relativistic condition. It's basically saying our new faster than light mechanics is the underlying system that justifies your existing framework, which works perfectly fine when the dollar particle is negligible.
So our physics is true for the objects with mass, but the field that initiates that mass operates outside of those limits.
That's the idea. And this dual geometry also explains antiparticles.
How so?
Because Ni particles always come in a pair, right? One for the positive mass-holding geometry, and one for the negative mass-leaving one.
So you automatically get a particle-antiparticle relationship.
Exactly. It accounts for what Dirac described, including the existence of the positron, right out of the box.
What's really astounding here, though, isn't just the theoretical alignment. It's the structural claims.
You mean the Lego connection?
The logo connection.
Yeah.
The final structural model of the nucleus and the atom that comes out of this theory is claimed to show the same view as the data from the LIGO experiment
I know.
for gravitational waves.
It's genuinely wild that a statistical theory about the smallest possible quantum unit predicts the structural data we see from, colliding black holes.
It suggests the structure of an atom is intrinsically linked to the gravitational structure of space itself.
That's a staggering piece of cross-scale evidence.
And it doesn't stop there, does it? The math for the Ni particle's energy and size also lines up with very specific established measurements.
It does. The calculations align with the Masonic X-ray detection of the nucleus radius.
Which is about 1.2 femtometers.
Right. And it also aligns with the measured binding energy of deuterons at about 2.225 MeV.
So whether you're looking at the energy holding a simple nucleus together, or the signals from colliding black holes.
The Ni mechanics seems to intersect with the established physical numbers we've already measured.
Okay, let's try to summarize these huge conceptual shifts this theory is proposing.
Okay, first I think is that field quanta are an inseparable union. That $1 plus $m equation is the bedrock.
Right, matter isn't a standalone thing. Second,
that mass acquisition isn't random. It's a geometrically required process governed by Ramanujan Entering and the Nishant Effect.
Then third,
that this geometry provides a unified structural model of the atom that finds this shocking alignment with massive astronomical data from LIGO.
And the big takeaway from that, according to Sharma, is that we can't keep using formulas that only rely on dollars.
Exactly. Force, energy, momentum.
Yeah.
They shouldn't just be a function of mass, they have to be a function of the union. Of one in a molecule. The non-intractable particle has to be formally included in the math.
Because it implies this continuous periodic system where creation is always prime, where the zero mass field is always feeding the mass field.
It's a self-sustaining mechanical loop.
So here's the final thought for you to really mull over. The theory suggests that Ni particles attend the field's nature, its geometrical rules, before they achieve physical intractable mass. Which leads to this general idea, and I'm quoting here, actions start before they come to sense, or actions start before their appearance seems physically.
Wow.
So what does that mean for our understanding of cause and effect? If the geometry dictates the outcome before the mass even appears, we spend our lives measuring the effects, but this theory implies the cause is invisible and faster than light.
The cause precedes the physical reality we can measure.
Think about that the next time you look at something that seems solid.